Hello everyone, welcome to this section. Here we are going to talk about something new which are called controller objects. And I'll start with replica sets and deployments. The first thing that you want to know is what is a controller? What does controller mean? Controller is something which is an object related to pod in some way or the other. Again, I know the definition is pretty confusing because there are various types of controllers available. For example, let's say you are running a pod or you have an application that have been deployed using a pod. Now the thing is that if the pod dies, it cannot come up. So you want to make sure that you have one pod running all the time, no matter what. Even if one pod dies, another pod with the same application or the same container image should automatically come up. So that is something handled by replica sets and deployments. So then there are daemon sets controller. So basically controller is one of an object which controls the state of a pod. You mention the desired state that this is what you want, and then it will go ahead and take care of the state of your pod the way you want it to be. Remember that this is not a control plane. That means this is not a master node with API server, scheduler, controller, and HCD. It is just one of the components, which is the controller component. It is not the entire control plane. And there are various types of controllers. One is replica set. As I said, if you want a number of replicas, it will go ahead and create those many number of replicas, and it will make sure that those many number of replica pods are running all the time. Then we have deployments, which is an higher level abstraction of replica set. And deployments are used to provide rolling upgrade and rollback features. Then we have daemon set and stateful sets for stateful applications and so on. So we'll discuss all these controller objects one by one. Then finally we have replication controller, which is an older version of replica set plus deployments. Replication controller has actually been replaced by replica set and deployment, but still it is pretty widely used. So we'll go ahead and discuss replication controller as well. One more thing I want to call out here is that we have various types of controllers. As I have already told you, we have replica sets, deployments, daemon sets, stateful sets, replication controllers. The concepts are actually interlinked. It might happen that some concepts of replica sets would be used in deployments also. Some concepts of daemon sets would be used somewhere else. So they're pretty much interlinked, and it's pretty difficult to have a synchronized way of telling all these things. So what I'll do is I'll use the hierarchical view of all these components one after the other. But it might happen that whenever I'm discussing deployment, I'll be bringing up replica set again. But even before going into the controller objects, I want to discuss something called labels and selectors. You already know what labels are. Labels are key value pairs attached to objects. Till now, we have labeled only nodes and pods, but you can label each and every object in Kubernetes. Whatever controller objects I have just talked about, we can label all those things. So labels are actually providing tags to Kubernetes objects. And the way you provide labels is like this. Under metadata, we have something called labels keyword, and under that labels keyword, we mention the label key and its corresponding value. For example, here we have two label keys. One is color and the other one is env. The color has a value of green and the env has a value of qa. So this is called a label. Whenever you put key value pairs under the labels keyword, you are essentially creating labels for that particular object. Then what are selectors? Selectors are nothing but selecting objects using the labels. We basically select like objects to make a group, and that's where selectors come into picture. And selectors use labels extensively. We cannot have any selector without a label. So if you want to group a particular set of objects, all those set of objects should have the same labels, and then we use selectors to select those objects with the same labels. Labels and selectors are very tightly tied to each other. We cannot have selectors without labels. And we can have two types of selectors. One is equality based and the other one is set based. Set based selectors are typically used in declarative statements using YAML file, and equality based selectors are mostly used in the imperative or the command line statement. In the set-based selectors, we select labels using two keywords. One of them is match labels and the other one is match expressions. I'll tell you what these two things are, but as of now you understand that we can select in various ways. The way match labels are implemented is something like this. You mention the match labels keyword and then the key of the label and the value of the label. So this env k8s training should be a label of any one of the objects. And match expressions are something like this. These are the two syntaxes which I'm showing you. In the next slide, I'll talk more on this using examples. But in match expressions, you mention the key, which is actually the label key, the operator. There can be various types of operators, and then its values, and there can be one or more values. So match labels are actually equality condition. If you see, environment should be k8s training only, but here we can provide multiple values of the same key. So if we use environment in match expressions, we can provide multiple values for env. And the operators are this: it can be in, not in, exists, does not exist. So let us see all these things using some examples. Let's say we have all these pods. We have 5 pods here, and all these pods are labeled like this. Pod 1 has env k8s training, another label is app python. Same is the case with pod 2. In pod 3, env is production and app is retail. So these are the two labels of pod 3. Whereas pod 4 and pod 5 have the same label. env is k8s training and app is Java. Let's say we have a selector like this, wherein I mention that match labels, and after that we mention the label key and the label value. So here we are mentioning that the select all the pods which has a label of key env and value k8s training. So you can see that pod 1, pod 2, pod 4 and pod 5 has the key env and its corresponding value is k8s training. So this selector will select all these 4 pods: pod 1, 2, 4 and 5. Now this is match label, so this is equality condition. Pod 3 will not be selected because the env is not equal to k8s training. Let's say another example. Let's say this is the selector and this time I'm using match expressions. The key is env, operator is in, values is k8s training. So I'm saying that match these two expressions. The first one is key should be env and its value should be in k8s training, which would select all the 4 pods because the key of all the 4 pods is env and all of them have the value k8s training. Now there's one more expression, so it will use both the expressions to select the pods. The second pod says that the key should be app and the value of app should be in Python, similar to OR condition. So here I have used only one value, k8s training. Here also I have used only one value, but typically this is an in OR condition wherein app can be equal to Python or something else. I have not mentioned something else here. But these two conditions are AND conditions combined together. So now if you see, the first condition would select all the 4 pods, pod 1, 2, 4 and 5. But the second condition, where app should be in Python, is only for these 2 pods. So this one would select only pod 1 and pod 2. Now let's take one more example. Let's say selector is something like this: match expressions, where key is env, operator is not in, and values is Python, which says select all the pods whose env is not equal to Python, and that is pod 3, pod 4 and pod 5. So this selector will select all these 3 pods: pod 3, pod 4 and pod 5. Pod 1 and pod 2 will not be selected because the app key contains Python. Sorry, it should not be env, it should be app. Let me change it. So I have changed it. So it's saying that app should not have a value of Python. So that's what it is saying. So it is selecting all these 3 pods, 3, 4 and 5. Now the selectors are mentioned in the manifest file, which we'll see later on. But remember that selectors are nothing but to select a set of pods or a set of objects. Here the object is the pod. I have shown you multiple examples how to use selectors using match labels and match expression. So remember these two things. Match label is a direct equality condition. That means that the key should have a value which is mentioned in the match labels. And match expressions, you can have a mix of or and. Each individual expression you can use either in, not in, exists or does not exist. And in the values you can have multiple values. That means it is giving you an or. Same is the case with the second one, but when you combine these two are ANDed. Now let's see a little bit more example of this. Let's say these are my pods and these are the labels of all the pods. All of them have three labels: env, appl, and tech. So environment, application, and technology. Now I'll ask a few questions and we'll see how selectors would work here. So I have already labeled the objects. In this case the objects are pod, as I've already told you. Let's see how selectors work. So this is the first question. In the manifest file somewhere, I'm mentioning that the selector or select the pods which matches these expressions using the match expressions keyword. So I'm using match expressions keywords here. Okay, the first expression is key should be env. So all of them have env, but it is saying that env should be in either QA or dev. So this is an or condition, right? The first expression is an or condition. So it is saying env should have a value in either QA or dev. That is the first expression. And the second expression is that application should be in backend. So here we do not have multiple values, so in actually translates to equal to. So these are the two conditions, and these two conditions has to be ANDed. That's how match expressions work. So pause this video and answer which pods would be selected. I hope you are done. So these are the pods that would be selected. So in the first condition which says env should be either QA or dev, all these 5 pods are selected, wherein env is either QA or dev. Okay, this is fine. But in case of the second condition, appl should be equal to backend. So pod number 2, or this pod, and this pod does not have appl as backend. So that's why these two are not selected. Remember that when you use match expressions, there can be multiple expressions. I have used only 2. In this case, all the conditions are ANDed. So after the second condition is matched, it comes out, or it brings out, or it fetches only these 3 pods with the green dots, because the application is backend. So this selector, wherein we have 2 expressions, or the first selector, wherein we have 2 selectors, it will select only 3 pods. Okay, let's take another question. And this question, this is the selector. We have combination of both match labels and match expressions. You can find this, you can use this one also. The first one is an equality condition, wherein the key is tech and the value is react. And in match expressions, I'm saying env is not in prod. So pause this video and try to find out the answer. I hope you are done. So let's try to analyze this selector. So in the first case, let's say the match labels tech should be react. So in this case, we have only these 2 pods, this one and this one. None of the other pods has tech with a value of react. So out of these 2 pods, let's see whether we can filter the match expressions. So it says key env not in values prod. So env not equal to prod, because it has only one value. It could have multiple values also. So not in means that the key env should not have a value of prod. But in this case, both the pods have env equal to pod. So for question 2, none of the pods would be selected because it is not matching any of the criteria. Let's take one more example, and this time we again have 2 match expressions. And the first one, it says that key tech should be in values either Java or Python. It is either or because the operator is in. And in the second case, key is env and the value should be in dev. Again, one value, so it should be equal to. So pause this video and answer the question. I hope you have got it. So these are the 2 pods, because this has Python and this has Java. There are other pods also with Python and Java. For the second expression, where env should be equal to dev, matches only these 2. So these 2 are dev. This is also dev, but the technology is Angular rather than Python or Java. So I hope the concept of labels and selectors are clear. If not, please go through the video again. And all these syntaxes that I have shown you here are actually written in the manifest file to select a set of bots. And this is very much needed for the rest of the section wherein we'll discuss replica sets and deployments.